Hello everyone and welcome to this talk about Klutch for Cloud Foundry, which is about seamless database management for Cloud Foundry and Kubernetes. My name is Julian Fischer. I'm CEO of Any9s. We are focused on building cloud automation, mostly evolving around application developer platforms and of course using Cloud Foundry and Kubernetes. So today in this talk, we are talking about an open source technology that we've created called Klutch. It's open source and it's aimed to orchestrate data services across various platforms, including Cloud Foundry and Kubernetes. Works across infrastructures, has Kubernetes and Cloud Foundry compatibility, and allows you to use data service and automation backends across lots of application clusters, a lot of Kubernetes clusters, while creating hundreds or thousands of service instances. It provides central control, pretty much like a cloud controller would in your Cloud Foundry environment, but beyond the limitations of Cloud Foundry. It aims to provide similar operational efficiencies as you would know from your Cloud Foundry environment. So it reduces operational overhead, and it supports the integration of arbitrary automation backends. It does all that using a Kubernetes native interface and is focused on providing the same on-demand self-service that you know from Cloud Foundry service brokers. Currently it leverages cross-plane, but that's a bit of an architectural discussion going on, whether this makes sense in the long run. So what is Klutch? First of all, the motivation for Klutch is pretty simple. Coming from the Cloud Foundry ecosystem, we are used to have a Cloud Foundry, then there are service brokers and some sort of data service automation backend. For us in our Cloud Foundry stack in particular, this means we have a Cloud Foundry, we have the Any9 service brokers, and they basically talk to the Any9's data services, for which, for all of the major open source databases, we have a BOSH-based on-demand provisioning automation backend. And, if all you need is Cloud Foundry, then that approach is just fine. It worked, for the past decade. We have tens of thousands of service instances being managed with that, and it works like charm, even when going through complicated issues such as with log4shell or shell shock. However, well, things have changed, and there's the elephant in the room, and no, it's not Postgres, it's, well, Kubernetes. So if you think about the data service challenge from the Cloud Foundry ecosystem, where to get the open service brokers from and how to implement data service automation so that it is of a quality to live up to the amounts of applications you can put on a Cloud Foundry, then you have to ask yourself, what does this mean if now Kubernetes is available in platform environments as well? For small-scale Kubernetes platforms, in increasing popularity, people use Kubernetes Operators. So you basically have your application running a few pods, and then you have an operator running a data service instance or multiple data service instances. And for, small environments, that works. But if you multiply that approach, then you basically end up in a situation where every application cluster also is a data service cluster, which means that the team that operates the application cluster, which in a lot of cases will be application developers, they'd also have to operate their databases. And not only dealing with the fact that they have a database, but they have to actually run the operator and maintain the lifecycle of the operators as well. And in our experience, that requires a skill set that's hard to scale across large environments with a lot of developers. So doesn't really scale that well. And this is where Klutch actually comes into the game. So let's have a look at Klutch and start with the application developer perspective. So if you're an application developer, what is it that Klutch will do for you? So first of all, the major change that Klutch introduces is that on the assumption that there will be multiple or even many application clusters, now there's a central Klutch control plane, and that central control plane allows the integration of arbitrary automation backends. That sounds familiar? It's structurally similar to the idea of having a cloud controller with automation backends integrated using the Open Service Broker API. Well, however, in Kubernetes, the Open Service Broker API didn't get very far because it is somehow a paradigm conflict, as it's not a Kubernetes native approach. So the idea of Klutch is, so to say, to take the Open Service Broker API legacy and move it forward into the Kubernetes ecosystem. So the resulting architecture postulates the existence of a lot of Kubernetes clusters on the left, which are here called Kubernetes application clusters or workload clusters. You have a central control plane where Klutch runs. Currently, we use crossplane for writing integrations, but there's also a path for writing your own Go-based operators. So Klutch uses crossplane, but it's not crossplane. It's not only crossplane, so to say. So, and then you have the automation backends, which could run basically on any infrastructure, both on premises and public. So Klutch, of course, as well as it is a Kubernetes workload, can run on any infrastructure that runs Kubernetes. The first idea that Klutch introduces is separation of application clusters from database backends. So we believe that, as shown earlier, it is not a good idea to have application developers take care of database automation and lifecycle managed database automation. It is fair to give them the operational responsibility for their database instances, but not the automation thereof. So how can you keep those things separate? Well, that's what we are going to look into. The way you achieve on-demand self-service for application developers in Kubernetes is you give developers custom resource definitions for service instances, service bindings, service keys for that matter, as well as backups and restore backup plans. So in contrast to the Open Service Broker API, Klutch comes with abstractions for dealing with backups and restoring backups, as this is essential lifecycle management functionality. And if you want to have true on-demand developer self-service, backup and recovery actions have to be comprised with the automation as well. So with the Klutch client, you introduce abstractions for all the data servers that are integrated with Klutch, so that application developers sitting in front of a Kubernetes cluster can basically act using Kubernetes as if they were in front of a Cloud Foundry and declare a service instance, declare a service binding, which will then create a local secret so that the application can read the secret and access the database. Pretty similar to what Cloud Foundry would do. Now the application developer's flow then looks a bit like this. So you kubectl apply your Postgres service instance spec, for example, which is applied to the local cluster, replicated to the Klutch control plane, similar to a cloud controller storing central information the Klutch control plane does, which will then reconcile with the actual automation backend. This could be your favorite Kubernetes operator, this could be 89's Postgres or Amazon RDS for that matter. Well, the service instance is then being created for you. Of course, this works on premises and public, assuming the automation backend supports on premises as well. Then the service binding is declared, and this establishes the connection between the application cluster and the automation backend. Of course, you can do that many, many times across many application clusters and many data services. So as you can see, application developers can declare and manage their service instances by talking Kubernetes to their local Kubernetes cluster. And you have in the Klutch control plane that central meta information. Speaking of which, the centralization of Klutch with its control plane is important, as it provides you with a similar approach to a cloud controller, giving you an overview of, for example, hey, what service instances of Postgres 15.0.1 exist, as there was recently a vulnerability, for example, is a question you could answer with Klutch. So the Klutch control plane is receiving all the declared states from its application cluster by using the Klutch client, which replicates those changes to the control plane. The Klutch connector is a set of Kubernetes operators that are quite lightweight and allow you to declare your entities, such as service instances. All these components are written in Go, and of course, Klutch only makes sense if you have all your automation backends integrated. So there's support for arbitrary automation backends, as long as they allow you to create service instance, service bindings, backups, and restore. So writing integrations is pretty straightforward. There are basically two ways to do that. That would be if something, for example, like Amazon already comes with a lot of cross-plane providers, you can use cross-plane to write integrations. Or if you want to do something that's not supported or quite cumbersome with cross-plane to do, which happens, you go for Go controllers and write those operators. So in an environment with a few Kubernetes clusters, this will look as the following. On the left side, you have multiple application clusters where application developers, throw their YAML specs for service instances, service bindings, backups, and restore at their local application cluster. Those objects and custom resources are then replicated to the Klutch control plane. And this is where the Klutch control plane reconciles with the actual automation backend. So in other words, the Klutch control plane introduces a cloud controller-like structure in a fleet of Kubernetes clusters. Well, it's Kubernetes workload and therefore works across infrastructure. So you can easily have, let's say in this example, 3 different Postgreses, where this is AWS Postgres that creates pods, A9S Postgres that creates VMs, and Amazon RDS that creates VMs as well. But as I said, you could easily add your own integrations, as this is open source. So the abstractions used by Klutch are heavily inspired by the Open Service Broker API, and we consider it Open Service Broker to be heritage and not legacy. So we don't abandon the Open Service Broker's abstractions, but we elevate them into something that's more declarative and event-driven, as you would assume for a Kubernetes native approach. The backup, restore, and backup plan abstractions have been introduced because they were lacking in the Open Service Broker API. We use those abstractions in the 89 data service for a decade now, and they work really, really well. Well, of course, not for every edge case they work exactly the same, but more or less across most of the, well, at least databases. That's a very valuable set of abstractions to have. So there are some differences too. Unlike the Open Service Broker API, we look at those abstractions more like a convention, but not a strict interface. So we allow different integrations for, let's say, Postgres to differ in structure. Because if you want to expose the underlying complexity of, let's say, RDS versus your favorite Kubernetes operator or any 9's Postgres, you will see that these functionality differ, and therefore trying to harmonize and have the same interface for all the data services will cut some corners that you don't want to have cut. And hiding everything in a flat list of key value pairs, as with custom parameters, is not the way to go either. So we strive for having a set of base attributes that should be supported by all the, let's say, implementations of Postgres, but also to enable a basic polymorphism where you can introduce your own attributes in your subclasses of the overall interface. So custom attributes are welcome, and we want to expose those in-depth functionality of backends, but not with a flat list, but a more structured, nested dataset. So we also support service plans, because a service plan is a tested configurations, a set of configurations. And while you want to be able to override service plan attributes in environments with highly skilled users, you still want to have proven service plans for situations where application developers do not have knowledge about how to configure a database parameter by parameter. So this is how a service instance looks in Klutch. As you can see, it's referring to the service, it's referring to a service plan, and gives that thing a name. You're exchanging a Postgres with a Postgres that creates pods with a Postgres that creates VMs, given that it is a very basic service instance, more or less the same. You can also switch and create a MongoDB instance, for example, and it's still more or less the same. As I said, the more complicated your configuration get, referring to in-depth functionality of that backend, well, the more you lose the ability to just swap from one MongoDB to another. But, well, this is not a regular use case, as we found out in the past 10 years. It happens, but not that often. And if it happens, well, some adjustments are fair to accept. Service bindings, pretty much the same. You have a name for the service binding. You reference an existing service instance. So service instance and service bindings, well, they have a relationship as they would have with a Cloud Foundry, where you also refer to the service instance when creating a service binding. Backup and restore, well, you give the backup a name, you reference to the service instance, and there you go. So restore, you reference to the service instance type and the backup reference. Basically, having a backup and restore is pretty straightforward too. You create a backup with a name and then you restore it. And how does this look like in action? Here is a Kubernetes cluster. You can see the Klutch connector, which is the Klutch client, running in an application cluster. And then you create a Postgres instance, similar to what we've seen earlier. Here, a few custom parameters are used. For example, max connections. A service plan is changed, and an attribute is changed from 50 to 20 connections. Well, apply the service instance, the YAML spec, and off you go. Klutch creates that custom resource in the application cluster, replicates it to the control plane, and the control plane reconciles with the automation backend. Once the service instance is created, you can declare a service binding. So you have to reference to the service instance name and the type. You apply the service binding, and off you go. Well, what do you expect from a service binding? Well, in Cloud Foundry, you would expect the vcap variable to be filled with the credentials that the application could read, and in Kubernetes, you create a secret that your application then refers to and is able to read the secret either as file or as an environment variable. Pretty straightforward. So, well, now the interesting part. Now that you have an understanding of what Klutch does for Kubernetes, let's talk about Klutch for Cloud Foundry. Because, today environments, they don't have just Kubernetes or just Cloud Foundry, but more likely they have both. Which means that you have a lot of application clusters, you have Cloud Foundry, you potentially could use Klutch to try to harmonize data service automation across those infrastructure, across your automation backends, as well as across your platform technologies. So we've introduced a component Klutch called the Klutch Service Broker. which is basically, well, straightforward, as Klutch supports the structure of Open Service Broker API abstractions. Why not map actions in the Klutch control plane, and provide a service broker for it? In this case, even a generic service broker. So let's have a look at how this looks from a Cloud Foundry. Well, not surprisingly, it looks like using a data service from Cloud Foundry, which means you can call the CF Marketplace and you'll get a list of service types available. And you can also see that the Kubernetes cluster below is empty, which is the Klutch control plane. So the marketplace functionality is given. Let's create a service. So CF service, no services are given. kubectl get Postgres instances, no Postgres instances are there. kubectl get logme instances, no logme instances are given. We look in the marketplace, we see that there are Postgres, 2 different variants, and there's also logme as a service. Good. Now create a service instance just like you would do with any other service from a Cloud Foundry Marketplace by providing the type and the service plan as well as an instance name. The service broker talks to the Klutch control plane. The Klutch control plane talks to the automation backend. And on the Klutch control plane, you should see a declared service instances soon. Now this Klutch control plane is, now the service instance for logme is created, similar to Postgres. And down below, you can see here a service instance for logme appears. There's the Postgres instance that we've created earlier. Both resources are created and ready. They will be in a few minutes. Well, once the service instance is ready, you can create a service binding as you would with any other service. Basically create a service key in this case because we don't have an app. All we want is the access credentials. And in the Klutch control plane, the creation of a service binding will create a service binding object as well as a secret. The secret is then also created in the application cluster where your application could read it. Well, but in this case, we don't want to create from an application cluster. We want to create from a Cloud Foundry environment. So here's the service key with the credentials you would expect. Hostname, username, password. And down below you can see there's Postgres connection to the, there's a Postgres connection to the service instance we've just created. So once you have created the service instance, you can also update the service instance, which basically translate Open Service Broker API calls to calls to the Klutch control plane and the modification of the custom resources introduced by Klutch. So you perform the CF update service here with the Postgres instance we've created earlier. And for example, you change an attribute to a different value. And there you go. Well, there's a typo, which means that there's a validation of the input as well in the service broker. And there you go. You have your service instance being an update. Well, of course, you can delete service instances as you would expect. And in the Klutch control plane, you expect once the service instance is deleted that the Klutch entity will also be deleted. All right, deletion in progress. Service instance is gone in both Cloud Foundry as well as the Klutch control plane. You can do that for logme as well. And there you go. Poof, it's gone. So, as you can see, Cloud Foundry and Kubernetes can live in harmony together, and with Klutch, you basically manage your data services across all those infrastructure and platform technologies. Klutch enables data service management across Cloud Foundry and Kubernetes platforms and infrastructures, providing on-demand developer self-service, integrating a wide range of data service backends. You can basically expose any backend in Cloud Foundry, well, including Kubernetes operators. Well, and as you've seen, you can also expose those Kubernetes operators in your Cloud Foundry now, which means that if you want to add Kubernetes operators to your platform, yeah, now there's a harmonized way to do so. You can expose those operators to application developers in Kubernetes and Cloud Foundry, while keeping operators at a central place, which means you don't have to co-locate them with your applications. Also, you integrate once with Klutch and use your integration across Cloud Foundry and Kubernetes, because the service broker that I've showed you earlier is a generic service broker, which means that you don't have to write your own service broker. All you have to do is write a bit of mapping code to map functionality between your Klutch entities and the attributes you want to expose in the Klutch service broker. But you don't have to write service brokers anymore. So right now, Klutch is fully functional. We do also have a network connector which allows to connect your application to the service instances, establishing a network connection. Because how would you, for example, access a database instance that's running on a different Kubernetes cluster, given that it's a different network? And we do have, an architectural approach with an interface, but also an implementation to try out. We have the Klutch Service Broker, which is now implemented in version 0.1, which is here still marked as upcoming, but it's already done. We have the Klutch Network Connector and integrations for multiple services. Amazon RDS is already done in the meanwhile. It is available. So now it's up to you, and get in touch with Klutch. Give it a star on GitHub. We are looking for sponsors. We are giving away free demos, and if you want to have a POC of Klutch on your infrastructure, just shoot us a mail. We'll schedule something with you. Also, there's a local self-demo of Klutch. You can download it to your laptop and try it out. And if you have any questions, feel free to reach out. I'm very much looking forward to it.